All right. And so here is the second half of the notes. I've had a couple of requests. The whole reason it wasn't in the classroom is something is wrong with the internet school. I've tried it at home. I had my daughter Emily take it to her work. I think I was able to get the first one uploaded now, so I'm trying this one. So this is some of the examples. Okay, this says an Algebra 2 final has a mean of 76 with a standard deviation of 7. So we know you take the data point minus the mean and divide by the standard deviation, and that gives you the z-score. Okay, well, we don't know, so we have two variables in this question, right? We don't know the z-score, but we know they want to know the 70th percentile. So that means that you beat everybody 70%. So you're in the 70th percentile, which is above the 50th, right? So if you go to that z-score table, you are literally, let me get my eraser here. I got to be on the positive side because I'm above 50%. Okay, I'm literally just going to look through this table and I'm looking for 70.7. Okay, so if I go here, I got 0.788, 0.19. Okay, so it's these two right here, this one and this one. Which one is closer to 0.7? That would be 0.6985, right? So that would be a z-score, 0.6985 would be a z-score of 0.52. So I'm going to go back out to this example. I now know the z-score because I knew the percentile. So, oh gosh, I already forgot it. Sorry. This is how much I've been doing to try to get this to upload. What was it? 0.52. Okay. So my z-score is 0.52. So now from here, once you get that z-score, it is easy to work. So you're going to go 0.52 times 7, because you got to get rid of the denominator, and then you're going to add the 76. So my answer is 79.64. Okay, that is what my percentile is. Okay, my percentile is 70%. Sorry, that's my percentage on the test, which is probably going to round to like a 79, 80%, right? Because I'm probably not given partial, but it could be there. Okay, that is an 80, but it is late, and I have tried this too many times today to correct it. Sorry. I'm on my last effort. So the next one, same thing. I don't know the z-score, and I don't know the score on the test, but I do know the 92nd percentile, which is pretty high. So I'm going to go to this table, and I'm literally going to find 0.9. I'm looking for 0.9. So let me get my little highlighter, 0.9. Okay, 903. Nope, 915. Okay, this one. That is the guy. This one. That is the closest one, 0.8997. That's almost 90%. And that is 1.28. So I'm going to go back to my example, and I'm going to say, okay, the z-score is 1.28. So I'm going to take 7 times 1.28, and then I'm going to add 76. So my score on the test would have been an 84.96. Okay. On the next one, it says, what is the probability between getting between an 84 and a 72 on the final? So if we use this here, and I'm just going to use this for both of these. I'm going to make my little chart, my bell curve. My mean is a 76. And then I'm adding 7, and 76 plus 7 is 83. And then I'm adding 7, and that's 90. And I'm adding 7, and that's 97. I'm subtracting 7, and that's 69. Okay, so that's my empirical rule stuff. I want to know between 72, which is not going to be one standard deviation away, and 84, which is going to be a little bit more than 1. Okay, so I want to know what is my z-score for if I look at 72, right? I'm going to do 72 minus 76 divided by 7. Find my z-score. 72 minus 76. I can't believe I just typed that in there. Divided by 7 is negative 0.57. Okay. I'm going to go to my z-score table, and I'm going to go to negative 0.57. So negative 0.5. I go over here so I can see it. Negative 0.57. 28.43%. That's what's below it. 28. So this right here below is 28.43%. Yes? Okay. And so now I'm going to do the same thing for my other line. So I'm going to say, okay, an 84 on the final. I'm going to do 84 minus 76 divided by 7. It's going to be a little more than 1. 84 minus 76 divided by 7. Little more than 1, 1.14. So I'm going to go to my z-score table. And I'm going to go, what was it? 1.14. So I'm going to go to my positive side. And I'm going to go to 1.14, 87.29. Oops, sorry. So that is 87.29%. 87.29%. So the question is asking, what is the probability of getting between there? Okay, so I want this. What is the probability of getting between there? So wouldn't I say 87.29? 87.29 minus 28.43. And my answer is 58.86%. Okay. All right, so I got a lot going on here. And you can pause, you can watch it again. I'm just going to try to erase some of this stuff because I don't need this. I don't need that orange line. See if I can get the blue line back in there for the next one. Oh, hell. That was bad. I told you it's been a long day. Sorry. I apologize. This is my mean, and this is 1 standard deviation below, and 83 is 1 standard deviation above. Right now I want a 60, which this would be a 62, which is 2 standard deviations below. So this is going to be like a negative 2 point something, right? And then I want 100, which if you think about it, this would be 2 standard deviations above. This would be 3 standard deviations above. So 104 would be 4. So it's going to be a high. Like this is a lot of your data if you think about it. So let's do the 60 first. 60 minus 76 divided by 7. 60 minus 76 divided by 7 ends up to be a negative 2.29. I'm going to find out what percentile that is. Okay, negative 2.29. So negative 2.29. So that would be 1.1%. Okay, 1.1%. So everybody else is going to score above them. So that's 1.1% below. So that's like 98.89% above. Again, apologize for my craziness. So then I'm going to do the 100. 100 minus 76 divided by 7. 100 minus 76 divided by 7 ends up to be 3.43. So I'm going to go to my z-score. I'm going to go to the positive side. I already forgot what my number was. No, I didn't. 3.43. Sorry, it's on my calculator. 3.43. 3.43. 99.97. Okay, 99.97. So I want to know what's going to score in between there. So I'm going to subtract those. 99.97 minus 1.1. And your answer is 98.87. Okay. And I know that's a mess, but I'm having to do this in a weird way to make it work. All right, example 3. ACT scores have a mean of 500 with a standard deviation of 100. What is the minimum score for the top 10%? So if you're in the top 10%, that means 90% is below you. Okay, and that's what a z-score is. It finds the ones before. So 90%, I believe we did that. It was right here. And that has a z-score of 1.28. Okay, so I know my z-score is 1.28. So I'd have x minus 500, because that's the mean, divided by 100 equals 1.28. So 100 times 1.28, and then I'm going to add 500. And my answer is 628. That's my score. Okay. For a normal distribution, separate the highest 10 from the rest of the distribution. For normal, find the z-score that separates the highest 10 from the rest of the so the highest 10, that would be 90% below. We just found that one. It's 1.28. That's not going to change. That's my z-score. That is how many standard deviations, 1.28 standard deviations from the mean. The lowest 20% means that it's 20% below. So that is, I'm looking for 0.2. So I'm going to go to my z-score. That's below. It has to be below. So I'm going to go to the negative side, and I'm looking for 0.2. Now, I did this one earlier, not 0.20. So let me get my bright red. I'm looking for, there's 18, 0.2. I want 0.209, 0.206, 0.2005. That's it. That is a negative 8.4. So my z-score is a negative 0.84. Sorry, you said it, but I didn't write it. That is my z-score. Okay. All right, we did that when I was showing it. So find the percentile rank. So the percentile rank is where everything is below it. So all I have to do is look up a negative 1.2, negative 1.2, and my percentile rank is 11. And it's down here. I don't know if you saw it in this bright yellow. 1.2 is 11.51. So my percentile rank is 11.51. Okay, and 1.52. So that's going to be on the positive side. So 1.52 is 93.57. It wants the percentile rank. Okay. For the numbers below, find the percent of cases falling above. Okay, well, you got to understand the z-score gives the cases falling below. So if I go to the z-score of 1.2, let's just find that guy. 1.2 is 88.49 below. So 88.49 below. That's going below. So I'm going to do 100 minus 88.49. And it would be, my answer would be 11.51% above. Okay, now this is different because, so negative 0.57, you're going to have to look on the negative side. Negative 0.57. Negative 0.57, I think I already did that one. 28.43. 28.43. This is how many are falling below. So I'm going to do 100 minus 28.43. And so it's 71.57% above. Okay. An 8th grader takes a standardized test with a mean of 140 and a standard deviation of 20. If he scores a 160, what's his percentile rank? So he's above, right? 140 and you divide by 20. So that's 20 divided by 20. Well, that's one standard deviation. We learned that. That's going to be 50 plus 34, so that's going to be 84%. So I can use the empirical rule on this. Now, some kids actually like the z-score, so they go to the table and they go to 1, and they write on their test 84.13. I will accept that as an answer. It's not multiple choice, so some kids actually use the z-table and get 84.13. This we used what we did Monday. This we're using the z-table. And that's what I was trying to say on Monday. Miss Byer just gets nervous about these numbers because they're not exact. Okay, on the last one, same question, 140. He scored a 280. 20. So I do 280 minus 140 divided by 20. And my z-score is 7. Okay, so I'm going to go to the table and, okay, this only goes to 3.49. It doesn't even go to 3.5. 3.49 is all it goes to. So and that's 99.98. So what percentile is this kid in? I would guess 100% because he's 7 standard deviations away. How realistic is this score? It's not. You probably have more of a chance of getting hit by lightning sitting in our classroom than you have getting this score on the test because it's 7 standard deviations away. That's well outside. That's an outlier is 1.5 standard deviations. So this would be considered way more than an outlier. Okay, so that should help you. Hopefully it